Hello and welcome to this IChemE Global Awards 2021 webinar. My name is Mara Kefalopoulou and I'm your host for today's presentation. The IChemE Global Awards celebrate chemical process and biochemical engineering excellence and are widely considered as the world's most prestigious chemical engineering awards. This award today we will be revealing the winner of the IChemE Sustainability Award sponsored by Johnson Matthey. This award recognizes the best project, process or product to demonstrate excellence in sourcing and consuming materials, reducing waste, and or optimizing product life cycles. So before we check out the contenders, let's hear from our sponsor. Please welcome Johnson Matthey's Project and Engineering Director, Ashley Anderson.
Hello. Can you just checking? I know I was told not to say can you see me, but can you see me?
Yes, we can see.
Yeah. Excellent. Okay. Yeah, got it. Okay. It was just slow coming through. Well, hello and good morning. I'm Ashley Anderson. I'm Director of Projects and Engineering at Johnson Matthey.
Sorry, Ashley, just to interrupt, we can't see you. I don't know if you'd like to have your camera on.
That might.
Now we can see you. Yeah.
Okay, right. So yeah, Ashley Anderson here, Director of Projects and Engineering at Johnson Matthey, and a very warm welcome to all the finalists in the Sustainability Award. It's with great pride that Johnson Matthey sponsor and present this award for sustainability again, as we've done for the last 2 or 3 years. Sustainability is one of our core embedded values.
I'm sorry to interrupt again, Ashley. If you have some slides to share, we can't see them either.
No, it's okay. It's just me.
Oh, that's okay. Okay.
No slides. So yeah. So the sustainability is one of our core embedded values is protecting people and the planet. The world's facing a set of complex challenges: climate change, the need for cleaner air, the drive for improved health, and a responsibility to be smarter and more efficient, in the way that we use the world's finite resources. So in setting, JM's vision for a cleaner, healthier world, we've made it our business to create sustainable technologies that address the challenges being driven by global megatrends. Sustainability is an integral part of our company, our strategy, and the decisions that we take. And as a leader in sustainable technologies, we apply our expertise in science and engineering to develop the solutions that create value for our customers and have an impact globally, making the world cleaner, healthier today and for future generations. So how did JM deliver that? Through different global sectors and clean air, efficient natural resources, health, new markets, and battery materials. In clean air, we're a global leader in catalysts and catalyst systems to reduce emissions from vehicles and industry, which serve the automotive and energy markets. In efficient natural resources, our products and processes transform, conserve, and recycle scarce resources using less energy and fewer raw materials across the chemicals, energy, automotive, and pharmaceutical markets. In new markets, battery materials, we apply our science in emerging opportunities such as battery materials and fuel cells, enabling the shift occurring in the automotive, chemical, and energy market. We have an immediate need. We all have an immediate need to address climate change and the expansion of the hydrogen, market. And Johnson Matthey has a very important role to play and significant expertise in enabling the transition to the hydrogen economy. Hydrogen is essential to meeting net zero emission targets, and we must all act now to scale hydrogen solutions and achieve cost-effective decarbonisation. JM's technologies are already at the heart of enabling the transition to a hydrogen economy. Our market-leading low-carbon hydrogen technology has been selected for groundbreaking blue hydrogen projects. And last year, we won the IChemE, one of the IChemE awards for that process. And our fuel cells technology is already out on the roads powering zero-carbon buses. And we're also applying our core science capability and market expertise to drive large-scale adoption of green hydrogen. Looking at the just looking then generally at the wider aspects of sustainability, there are three main pillars of sustainability. They're really environmental, economic, and social. They're all interdependent. And in 2015, the United Nations established 17 sustainability development goals, which essentially are the blueprint to achieving a better and more sustainable future for all. They address the global challenges faced: poverty, inequality, climate change, environmental degradation. And Johnson Matthey's goals are orientated with these UN sustainability goals. Turning briefly to climate change, the landmark report by the United Nations Intergovernment Panel on Climate Change paints quite an alarming vision of the future if we collectively don't endeavour to decarbonise our economic systems and stabilise the level of greenhouse gases in the Earth's atmosphere. Consequences of inaction include threatened ecosystems and biodiversity, water and food scarcity, rising sea levels, increased ocean temperature and acidity. The report considers various pathways for atmospheric CO2 reduction to limit global average temperature rises to 1.5 degrees. And to try and reach net zero around 2050, it's worth noting if delaying net zero to 2070 is projected, it's projected to lead to around a 2-degree temperature rise, with increasing issues for the planet. And really, to gain an overview, the IPCC produced a summary report on global warming, and that's actually, it's a short read, but it's very well worth reading to try and understand the consequences of inaction. Looking ahead, the United Nations to next month, United Nations COP26 Climate Summit in Glasgow takes place, with the main aim to secure a global net zero by mid-century and keep 1.5 degrees within reach. And to do this, all countries have been asked to come forward with ambitious 2030 emissions reductions targets that align with reaching net zero by the middle of the century. As a chemical engineering community, I think we have a unique ability to understand and analyze whole systems. And the community will be front and center in the drive for sustainable life on the planet. Examples of sustainability innovation in industry are showcased by the excellent finalists in this IChemE award category. And just finally, as engineers and scientists, I believe we all have an important responsibility to take the time to understand the impacts of global warming and the pathway to net zero, and to help explain the immediate need to address climate change to the wider population. So that's my opening words. And as we proceed with the IChemE Sustainability Award ceremony, I wish you, all the finalists, all the best of luck in a very strong category. And with that, I'll hand you back to Mara.
Thank you, Ashley, and thank you once again to Johnson Matthey for its continued support of the IChemE Global Awards. And now then, our judging panel has been working hard in recent weeks to review and rank all the sustainability award entries, and here are our finalists. Clariter, Dow USA, Dow Belgium, a joint entry from Future Bay and Otto Simon, 2 entries from Saudi Aramco, and finally winners of the IChemE Malaysia Sustainability Award, the University of Malaysia Sabah, Commerce Galaxy, Palladium Consolidated Industries, Zeta, and the Tokyo Institute of Technology. All of our finalists join us today to answer your questions and tell us more about the work. You can ask your questions at any point during today's webinar using the GoToWebinar questions box on screen. So let's get started with our first presentation. Representing Clariter is Jasper Mounier.
Yeah, thank you all, and thank you for these great words as introduction already. It's a great honor to be here. Let me take a minute to set up my set it up. Hold on. Okay. Can you see my screen?
Not yet.
Not yet. Okay. Mara, I believe you were the helpline, right? How to set it up?
Hi, Jasper. It's Cassandra as well here.
Cassandra.
Have you seen a pop-up come up on your screen that says, "I've just sent it through again"?
No.
Have you got
No.
two screens, Jasper?
Yeah.
Okay,
Got it.
not to worry.
Now,
Sure.
I got
Oh, you've got it. Lovely.
I got it. Thanks. Let's see here. All right.
We can see your
Now
screen
you see
now.
it, right?
Yes.
Great. Fantastic. Well, thank you so much. Okay. Well, I'm here to tell you about Clarity. It's a great honor to be among the finalists. Absolutely a great honor. Clarity is a company where I started with gray hair, if you will. We've been around for 18 years working on a future-proof petrochemical process. For decades, the world has been looking for solutions to reduce plastic waste, which is a tremendous problem, as we all know, but also reduce the dependency on crude oil, empower local communities, and clean our planet. Well, all these combined is at the heart of what we as Clarity are doing. We take the plastic waste that nobody wants, which cannot be mechanically recycled, and ends up either in landfill or incineration, and turn them into products that everybody needs on a daily basis. And we do this via a very, very unique process, which I'll tell you more about in a minute. But first, as I mentioned, plastic waste obviously is a huge problem, which we need to reduce, either or reuse plastics or recycle. Plastic itself is not really at the core of the problem. The problem is what we do with the waste. Up to date, as I mentioned, we have been developing our process for the past 18 years. And we're doing this with a tremendous team, an R&D team in Poland, and a tremendous team in South Africa. We have our first continuous scale plant, our R&D plant in East London, South Africa. And here we transform the plastic waste via a three-step process. First, we thermal crack it. Then we have a unique hydrorefinery process in which we have the pyrolysis oil being refined based on hydrogen. We take out the double bonds, the sulfurs, the aromas, all the impurities, and after that we distill it and we separate it into three product families: our solvents, oils, and waxes. This unique process creates products that are at the greatest, highest purity and can be used in numerous of applications, whether it's from shoe cream or lamp oil or surf wax, you name it. The opportunities are endless. Basically, because it's a high purity, we have a 100% drop-in. We create a 100% drop-in that can replace the crude-based oil products, our incubants for our products, make it much more sustainable. So all the products you see here in front of you, and which you can see here behind me as well, are made out of plastic waste, which is obviously, as we call it, upcycled. So it's upcycled plastic waste into these chemical products. Our products have been tested over and over again. They meet FDA purity levels. We have reached registration in Europe, and currently, as you saw just yet, with our scale plant in pilot scale plant in South Africa, we're up for the next big phase in our existence, namely our full scale plants, which we envision first off in the Netherlands, Poland, and in Israel. And there we will process 60,000 tons of plastic waste and turn that into our beautiful product you see here, which is 50,000 tons. So basically, we have a yield of 85%, which is very high in this field of work, and all that with an LCA that CE Delft conducted a year ago, which shows that we are carbon negative. So for every ton of plastic waste, we take out roughly 1 ton of CO2 for the replacement of crude oil, which is a product-to-product LCA for those who are interested in it. And this all is a unique proposition we're very proud of. As from the Clarity family, I can tell you we are a very international company. Mainly, I'm talking to you here from the Netherlands, but we have a team in Poland, an R&D team, our team in Israel, and a team in South Africa. It's all patented, and obviously, we're always open for new partners, investigating new solutions and new applications, and people are interested in joining us in our next steps for our full-scale plant. So that's very short what we do, and again, we're very proud to be here as a finalist, and thank you for your attention.
Thank you, Jasper. We'll now turn to questions and answers. So if you have a question, please get in touch via the questions box. We actually have our first question, Jasper. May I know the energy intensity of this process? I have a question here.
Yeah, so it's I can't give you exact numbers, obviously, but what I can tell you that the energy intensity of chemical recycling in general, and also our process due to its pyrolysis, is high. It's a high energy intensive process. We need to heat up the plastic waste before it enters into our refinery unit, obviously, in order to get the hydrocarbon mix. So it's a very energy intensive process. But nevertheless, as I just mentioned, we are still CO2 negative. Yeah.
Thank you. We have quite a few questions here. So the other question is, one of the issues is the logistics of collection of material. I'm doing some work with NHS in the UK, and they have the desire to minimize waste, particularly single-use plastics. However, there are issues with collection. Have you experience in the? Do you have an experience in this sector?
Absolutely. So as I just mentioned, what happens is that we take the plastic that nobody wants, meaning that in the collection system, it goes to the sorting facilities. The sorting facilities take out the plastics that are valuable and can be used in mechanical recycling. They end up with a mix. So it's a mix of all types of plastics. What we do is we take those mixed streams which are normally used for incineration in northwestern part of Europe, and we further sort those streams out. We clean them, we shred them, we wash them, and we dry them, and then we use the polyolefins. We only use the polyolefins because our system is designed that way. We can't take in PVC, we can't take in PET, unfortunately. I mean, these gives contaminants to our reactor and our catalyst, but we take out the polyolefins. So basically, that's a pre-treatment step we take in order to make sure that we have a very clean feedstock at the front end, resulting in a very clean output of our products.
Thank you. The next question is, does the product impact due to feedstock?
Sorry, come again? Does the product impact due to feedstock?
That's the question I see here.
Yeah, so what I just mentioned is, yes, obviously we can't take in dirty plastics, right? We need a clean feedstock in order to have a clean output in our product. And we have high purity products, as you can see behind me. These products are transparent or snow white, but in order to reach that, we need to pre-treat the sorting. And as I mentioned, since we have a petrochemical boutique, we sell deep into the market. Meaning, if we can sell deep into the market, we have very good economics, resulting in the fact that we can have more and more investment in the front end to clean our feedstock.
Thank you. And the last question: how sensitive is your process to the wrong types of polymer, such as PVC, being fed?
Yeah, absolutely, good question. So PVC creates chloride, which is tremendous bad for our catalyst. So we cannot take in PVC. But luckily, as I mentioned, our pre-treatment process, we have very good equipment in order to take out PVC and PET. So we take out as much as we can. Now, as you can imagine, processing 60,000 tons of these plastic waste streams at the front end results in a stream of 7.5 tons per hour. So that is a lot of plastics. What we obviously have designed is to be robust enough to take in a few percentage of these contaminants. It doesn't really hurt us that much, but most of it has been taken out before in order to secure that we only have polyolefins, which can be rigid on one hand or fluffy material. The wrappings. Yeah.
Thank you very much for getting things started, Jasper. It's time to move on to our second presentation from Dow USA. Please welcome Wendy Xu.
Yep, good morning. Let me share my slides. All right, so good morning, everyone. Hold on. It's my pleasure. I'm Wendy Xu, application scientist at Dow Chemical. It's my pleasure to share our product, Bio SPF Booster. It's a bio-derived and biodegradable product to improve the sun protection and reduce the environment and health impact of the sun care ingredients. So why sun protection, you may ask? As we know, the UV exposure is a primary cause of non-biological skin cancer and skin aging. And the American Cancer Society reported that in 2018, more people were diagnosed with skin cancer in the US than all other cancer combined. As a result, the sun care market is fast growing, outpacing most of the other segments in this multi-billion personal care industry. Now, UV actives are the key ingredients to block the harmful UV radiation and protect our skin. However, they have triggered health and environmental concerns because they tend to bioaccumulate in our body, and then they can potentially bleach coral reef and impact the marine ocean ecosystem. So many of the UV actives have been facing the deselection, make it challenging to formulate high SPF sunscreens with a good sun protection. Now, using SPF Booster is one solution to improve the UV blocking efficiency of the sun care products. However, because many of those leading SPF boosters are non-biodegradable and they're not bio-based, they are facing the regulatory bans as well due to, for example, microplastic concerns. So therefore, in this industry, delivering sustainable and high-performing sunscreens is a major challenge. Towards that, we developed this new product called the Bio SPF Booster. It is a bio-derived from wood pulp, and it's a patented technology from wood hydrolysis. The wood is responsibly harvested. It has 100% renewable carbon, and it's derived natural according to ISO 16128 with a natural origin index of 0.97. It is also readily biodegradable, confirmed by the OECD 301F test. And this product has been recognized by a few global awards, if you see here. Now, how it works. So the scattering mechanism is through UV scattering. If you look at the illustration here, the scattering can increase the optical path length of those harmful UV light in those sunscreen film, which is acting as a protection film on our skin. And then it increases the probability of those harmful UV radiation being absorbed or consumed by the UV actives. Therefore, it can increase the sun protection factor of the sun care products. So we tested them in a variety of formulation chassis. As you may be aware, that the sun care products, it's a lot of formulation chassis and how we make sure it can work. So you can see that in the red bar, this product can boost the protection in a variety of formulation chassis. This is the in vitro test. We also did the in vivo test done by a third party, directly test them on human body according to the FDA protocol. And you can still see that this product in one of those formulation chassis doubled the boost efficiency of the leading synthetic benchmark. And that allows anywhere from 30 to 40% reduction of UV filters by only using 1% of this sustainable SPF booster. And we also tested it in a different formulation, tested with all inorganic UV active zinc oxide, titanium dioxide. If you look the label at the back of the sunscreen bottle, and again, we see a very significant boost of this product. And one of the kind of drawback of sunscreen that disencourage consumers to apply to the skin is the sensory. This product shows to improve the sensorial profile of the sunscreen, make it less tacky and less greasy. This will help the consumer appeal as well. In addition, so to the SPF boosting, this product also can thicken the water. So this is a additional and added benefit comparing to other SPF boosters. So this allows this product to act as a rheology modifier and replace some of the synthetic or non-sustainable rheology modifiers in the sun care product as well, like a 2-in-1 kind of product. Also, if it was found to have very superior shear thinning, as you can see here, a lot of technical details, I won't go into details, but shear thinning is highly wanted in any consumer kind of lotion type application. It enables good spreadability and good sprayability through a pump spray. Again, the last one is usually the sunscreens, people don't want to look white after you put on. So this product enables transparent film on the skin. So overall, this is a crystalline cellulose-based technology that has high performance and multifunction. And it not only enables higher sun protection to help reduce the non-biological skin cancer and skin aging, but also it reduces the environmental and health impact of the sun care product overall. And so with all that, I'd love to have you to answer questions.
Thank you very much for that presentation, Wendy. Once again, it's time for your questions. So if you haven't already done so, please get in touch via the questions box. And whilst I give you a moment on that, don't forget there are more IChemE Global Awards webinar coming up this week. So you can find all the dates and time by visiting icheme.org/global awards. I don't see we have any questions, so thank you very much, Wendy, again. We are going to move on to our third finalist of the day. It's Dow Belgium. Please welcome Thomas Davidian.
Hello, good morning, this is Thomas. Can you see my full screen mode?
I think, Thomas, you need to go on the top left of your screen and change the display settings. Yes, that's better now.
Is it okay now?
Yes, thank you.
Okay. Thank you, Mara. Well, thank you to IChemE for organizing this event and giving us the opportunity to present today. Good morning, good afternoon, good evening to all. My name is Thomas Davidian. I am research scientist at Dow in Senef in Belgium. I will be presenting the development of a new transparent silicone spacer for insulating glass applications called Dow-Sil Crystal Clear Spacer. In order to increase thermal efficiency and reduce CO2 emissions, supermarkets and retail stores look for improvements in the insulation of their commercial fridges. For some years now, supermarkets have equipped their fridges with single-pane plexiglass doors. However, the next step of thermal efficiency, meaning going to double glazed panels, shows some technical challenges. For supermarkets, it is critical to maintain full vision for the customer to be able to see the goods, and therefore opaque frames in aluminum or PVC cannot be used. The objective is therefore to replace the opaque frames by transparent, vertical elements placed between the glass panels, which we call the spacers. Some rigid transparent spacers in PMMA or polycarbonate have been developed, but these require a tape to adhere to glass, as these materials cannot develop chemical adhesion to glass by themselves. This can cause long-term durability issue, eventually leading to fogging and loss of thermal efficiency. Our team at Dow has developed a silicone spacer based on a novel two-part condensation cure chemistry. The formulation was optimized by balancing some key properties such as transparency, hardness and elasticity, and adhesion to glass. Formulations were scaled up, and an on-purpose spacer production process was developed. This allowed us to sample customers with pre-shaped spacers and optimize the formulation based on their feedback. Eventually, a two-component formulation called Dow Seal 2255, Part A and Part B, was selected. The resulting cured material is crystal clear with durable transparency. And this new chemistry provides a unique property of chemical adhesion to glass, even when the spacer is fully cured. As you can see on the picture on the bottom left, the strong adhesion of the spacer to the glass panes, also showing the good flexibility of the spacer. Moreover, the lower thermal conductivity of the silicone material enables up to 4% improved thermal efficiency over doors made with PMMA spacers. Both the formulation and the production process have been patented for a robust insulating glass solution. The assembly process of the insulating glass units with our spacers is pretty straightforward. In the first step, the glass panel needs to be cleaned and primed with the recommended primer, and let 5 minutes for the primer to react with the glass. After that, the silicone spacer can be placed onto the glass on both sides and covered by the other pane. After 5 minutes, the spacer is chemically bonded to the glass. Eventually, a secondary seal can be added and the assembled panel can be moved to storage. The Dow Seal Crystal Clear Spacer is intended for air-filled insulating applications in commercial fridges. Its flexibility allows also the design of curved shapes for specific applications. The picture on the right shows a fridge in a supermarket equipped with our spacers that was used to demonstrate the durability of the silicone solution. After several years in service, no loss of adhesion or fogging has been observed. The Dow Seal Crystal Clear Spacer was developed thanks to a close collaboration between Dow's technical and commercial functions in Europe in interaction with insulating glass and fridge manufacturers. Thanks to this teamwork, Dow Seal Crystal Clear Spacer was successfully launched in 2021, despite the COVID-19 and the sanitary restrictions. More information on the Crystal Clear Spacer can be obtained via the QR code or the link shown on the slide. Thank you for your kind attention.
Thank you, Thomas. We'll now once again pause for questions. We'll give you a moment to get in touch now. And whilst we wait, the winner of this award will have a chance to lift a second prize before the end of this month. All our team award winners qualify as finalists for our top prize, the Outstanding Achievement in Chemical and Process Engineering Award, and we will be announcing the winner of that award on Friday, 15 October. I don't see, we don't have any questions. We have one question just came in. What is the advantage of being flexible front? What is the advantage of having a flexible front panel?
So the fact that the spacer has some flexibility allows it to absorb mechanical shocks upon opening and closing of the doors, and also upon repeated opening and closing, you will have let's say less chances of breaking the glass panels.
Thank you. Thank you very much again, Thomas. It's time to move on to our fourth presentation. Next up, we have our joint entry from Future Bay and Otto Simon. Please welcome Adrian Hutchings.
Good morning. I'm very pleased to be here and talk to you about the novel Future Bay thermodynamic cycle for energy storage and the project that we undertook with Otto Simon to build the first demonstration unit and show the performance of a system that we believe can have significant impact in moving us towards a net zero future and improve sustainability of energy utilization. We see a number of issues that have been growing across the world in terms of needing to be able to use renewable energy far more effectively, and to do so we need energy storage. Currently there are battery-based systems which are very good, but they have issues in terms of cost. They use exotic materials and there can be some safety issues. So is there a different way of doing this at a lower cost in a more benign way? We also see, and it's a particular bugbear of mine, is the absolute racing ahead demand for cooling. The International Energy Agency's report on the future of cooling is actually quite frightening. They believe that the stock of air conditioning units will increase over the next 30 years, and it will increase from 1.6 billion units today to 5.6 billion. That actually amounts for 10 new air conditioning units being sold every second for the next 30 years, which is terrifying. You know, that will need electricity, the combined electricity capacity of the United States, the EU and Japan of today will be needed to supply those air conditioning units. How can we reduce the amount of energy that air conditioning is demanding? How can we stop the hot air that is put out of the back of air conditioning units from going into the atmosphere and raising the temperature further? Those are our two main areas of concentration, but we also, with this new thermodynamic cycle, we can capture waste heat down to very low temperatures, as low as 50 degrees C, and convert that back into usable energy. And in the EU alone, we're throwing away 300 terawatt hours of heat a year. There's also a drive to decarbonize heating, and almost as a side benefit of our system, we can provide space heating and we can provide domestic hot water. So the system that we have produced, the Future Bay unit, can deliver long duration energy storage at actually quite low costs. The reason being the main storage medium is water, and here you can see a tank. That's one of the tanks that we would contain the energy in. We can deliver waste heat to power, and we can deliver cooling and heating all from a single system, which is based on well understood refrigeration type equipment for easy installation, operation and maintenance. So this system will not only enable us to shift loads from peak requirement times to off-peak times, allow us to use renewable energy when wind isn't blowing or when the sun isn't shining. We can also reduce energy consumption for the provision of cooling and heating, and we can do it in a very inherently safe, non-toxic and environmentally benign manner. So let's talk about this new cycle. This is patented. We have 2 patent families covering over 100 inventive steps, and those patents have now been granted on a global basis. At the center of the system, we have a heat pump, which is energized by low-cost off-peak renewable energy. And that creates two thermal stores. So effectively, the same as any heat pump, you're moving heat from one side to the other. So we create a cold store in water and we create a hot store in water. And the way I like to look at this, as I say, it's a very inherently safe. The cold store isn't as cold as your freezer and the hot store isn't as hot as your kettle. So we've no extremes of temperature, we've no high pressures, and we've no exotic or toxic materials. So it's very straightforward. Once you have a hot store, this is a very standard organic Rankine cycle for the generation of power. And this is a well-known technology. And we use the heat to evaporate a working fluid, which drives a turbine. And then we condense that vapor back into a fluid and it goes around the cycle. So we can bring in cool air here from ambient and we can heat it up and provide space heating and or hot water if that is required. More novel is the cold side, which is effectively the same, but what we're doing here is we're using ambient or waste heat or solar thermal or any other viable low-grade heat source to do the evaporation. We produce the vapor to drive our turbine, and then we use our cold store to condense that back round the loop. Now that can provide a very useful service in terms of cooling, in terms of air conditioning and or refrigeration. So it's a multi-benefit system. As long as you need storage and cooling, it's very, very economically viable. And the other elements are effectively side benefits that it delivers on top of that. These systems operate totally independently. So you can do the hot side at one time and the cold side at another. And that can bring benefits as well. So if we actually look at the sort of systems that we're looking to build, this is the first unit that was built for data center cooling up near Manchester that we built with Otto Simon. This is a containerized system. The heat pump that we used was an off-the-shelf heat pump that normally is used producing ice for an ice rink. And then we used 2 organic Rankine cycles, normally used for biomass on farms. And I spoke earlier about the separation of the two sides. So you can envisage applications such as a hospital that might be in an area where power is less than reliable. You can look at having solar associated to drive our system to provide viable power on a 24/7 basis. We can also provide cooling if it's in a hot environment. We could take waste heat, say from an incinerator, to produce extra power, and there's plenty of hot water being required. You could also look at, say, a hotel. In the morning, people are going to need hot water for showers. We can produce that whilst producing power from the hot side of our system. During the day, we can be taking in power from solar or other renewable sources. People come back to the hotel in the evening and they want to have the air conditioning on. We can provide that without putting a peak onto a network. So we are able to shift the loads and reduce the loads on them. We built this unit as a demonstration for Electricity Northwest Limited, a distributed network operator operating in the northwest of the UK. It was built under an Ofgem National Innovation Allowance, and Otto Simon worked with us to do all the principal engineers. You know, they're our engineering team, and they helped deliver this on time and highly successfully. I won't speak for Otto Simon. This is their background. They are a highly professional, very skillful team. What I would say about them from the sort of customer side is they're extremely good at communicating, both reactively and proactively, which is great. You don't have to wait to find out what's happening. But I think the other thing that's been really surprising for us is that they're extremely passionate about this project. They believe, as we do, in the benefits that it can bring and the importance of it, and that passion comes across in the work that they do with us. The project, as I say, was very successful. This is extracts from a report that Electricity Northwest made to Ofgem on completion. And what we can see here is it shows that we can reduce net electricity consumption as we take the heat that would have been wasted. We reduce CO2 emissions by using electricity that would be produced at night time with lower CO2 burden. And we reduce peaks on their network by producing peaks that would have been normally used during peak time. We could effectively reduce, in this particular application, the air conditioning consumption by up to 50%. And we shifted the load off their network, which was extremely important to them, by 150%, because we took the load that would have been used during peak hours and shifted it to off-peak, and we produced electricity during that peak time as we delivered the cooling. So that's the future-based system and the work we've done with Otto Simon. We're currently now looking at doing some more projects, and very welcome and would like to talk to people if they've got ideas for this application. So if there's any questions, I'm happy to take them.
Thank you very much, Adrian. We have a question. What is the largest installed and working until that is in operation today, and how many units have been sold of that size?
Currently, there is only the one unit, which was the demonstration that we built for Electricity Northwest. Let me go back to this slide here. This was looking at tens of kilowatts of electrical storage. We have done a design with Otto Simon where we could see ourselves going up to very large grid scale on a module basis. So we would use modules to take us up to the tens of megawatts of electrical power and long duration. So this would be a 70 megawatt hour storage system. The nice thing about this is, because we're talking about tanks of water as the storage medium, you can add duration extremely easily. So this very large system would be built up out of this type of module, which is in the hundreds of kilowatts. This is about a 250 kilowatt 5-hour duration module.
Thank you, Adrian. We don't have any other questions, so thank you again. Actually, we have one that just came in, Adrian. You're using waste heat. Is enough energy really available? What temperature might be needed, please?
We can operate down to 50 degrees C. I think if we would normally operate at around 90 is very efficient for us. We don't need to have the waste heat because we're actually taking our own waste heat. When you operate the heat pump, you are effectively using heat here. So we can actually take ambient as our material to be warmed.
Thank you very much, Adrian. We don't have any other questions. So let's move now to our next presentation. From Saudi Aramco, please welcome Sanil Kokhal.
Hi, can you hear me?
Yes, we can hear you, but we cannot see your screen, Sanil.
Okay, because it's bringing me to some privacy setting.
Did you receive a pop-up to share your presentation?
1 second. Okay. Can you see my screen now?
We can see you, your camera.
Okay, let me see.
See your presentation.
Can you see the presentation now?
No, you must have received a pop-up message to say to accept to share your presentation.
Can you send me the pop-up again?
Yep, Hi, Sunil. I'll send you through to you again. One moment. Okay, that should have popped up now.
Yes. Can you see the screen now?
Not yet.
I'll just talk you through one other way to do it, Sunil.
Yes.
There's a bar across the top of the GoToWebinar control panel that's called sharing.
Yes.
If you expand that out, on the left-hand side, there's a little arrow and you can make it larger. And it opens up, and then you can see a big play button with a drop down below it where you can select what you'd like to share. So you can select your screen or
Not showing anything.
okay. Do you see what I mean by the sharing area on GoToWebinar panel?
Yes, I have
Yeah.
that. It says not sharing anything. And then it says there's a pause button and show.
Okay. Oh, there you go. You got there. So we can see your screen now if you want to make that full screen.
Got it?
Yeah, we've got that. That's lovely. Let me just wait to go full screen for me. Perfect.
Yeah,
Over
that's
to you.
fine.
Thank you.
Okay. Good day, everyone, and thank you, IChemE, for shortlisting our project for this event. Excited to be here. My name is Sunil Kokal. I'm a principal scientist and a focus area champion for CO2 sustainability and enhanced oil recovery at Saudi Aramco, based in the Haran, Saudi Arabia. This project, CCUS and CO2 demonstration project, is part of the company's what we call circular carbon economy framework, a holistic approach to reducing our carbon footprint. CCUS, as you may know, will be an essential part of any solution to global climate change. So what I'm going to show you today and demonstrate some real solid data in terms of how much we have sequestered. So just to start off, project overview on the CO2 and CCUS project is the first of such kind in the Middle East region. Captures up to 800,000 tons of CO2 every year and pumps it into a reservoir in Uthmania, which is part of the greater Gawar field. There's a pipeline about 5 kilometers, and then it is injected into that reservoir, which is the Arab D, the main reservoir from which 4 to 5 million barrels of oil come every day. Here are some of the project details. There are two major components for this project: surface, which includes the CO2 capture, dehydration, and compression facility, and subsurface, which includes the injection and production facilities. So the project has 4 injectors, 4 producers, and 2 observation wells, and these were all designed and built specifically for this project. The wells are all equipped with downhole sensors, measurement devices, automated valves, so we can look at the data real time, almost real time, on our computers and our desktops. The project has become a test bed for deployment of Generation 2 intelligent field. And the bottom part of the slide shows you the timeline for this project. And I want to emphasize that this project initially started in 2006. CO2 injection started in 2015, and we are still ongoing with this project. Just to give you a time scale of a project like this, so when you hear in the media, CCUS is going to be a solution, remember it takes time. Okay, so here is the actual data in terms of starting in February 12, before CO2 injection started. You see a general decline. I don't know whether you can see my pointer. CO2 injection started in 2015. The green is the oil, red is the amount of CO2 injected, and brown or orange is the gas produced. And on the top you see in blue what we call water cut. And so you can see that the green curve increased after the water pressure, after we started injecting CO2, and it has been hovering around a significant amount high, much higher than what we were getting with the water case. In terms of the big picture, whatever amount of CO2 that we have injected, which is shown here, 48 billion standard cubic feet. Of that, we have produced back 20 billion standard cubic feet of CO2, and therefore the CO2 stored is about 28 billion standard cubic feet, which amounts to about 1.5 million tons. So this is actual number of CO2 that has been taken out of the atmosphere and put back into the reservoir. So in terms of our objectives, which was to sequester the CO2, 28 billion scf has been sequestered so far, and the project is still continuing. We have had some positive gains for oil, and there has been an increase in recovery. We have deployed a lot of technology. We have left no kind of stone unturned in terms of deployment of technologies, new technologies, some for the first time in the Middle East, some for the first time even in the world. And right now we're in the process of assessing the results, which has been extremely positive, and writing a report. In terms of by the numbers, the first CCUS project in the greater Middle East, North Africa region, oil response has been very good. It has increased by about 4 times the water flooding rate. About 59–60% of the CO2 that has been injected is retained in the reservoir. We are injecting 2,000 tons of CO2 per day, which is equivalent to removing 170,000 cars from the road per year. So it's really a win-win project, a win for the environment and a win for getting some additional oil recovery. It has been a safe project, 17 million hours without any major incident, 10 number of international awards won by the project, prestigious awards, I would say. And in terms of HSE, we have addressed all aspects of health, safety, and environment at each stage of the pilot implementation. We are doing a superb job, in my opinion, in terms of monitoring and surveillance. We are monitoring the amount of CO2 that is going in, the production rates from the wells, and from there we calculate the amount sequestered. We are also monitoring CO2 inside the reservoir. We have deployed seismic, we have deployed tracers, we have deployed advanced logging techniques. So we are monitoring the plume within the reservoir, and also, which is very important, the oil saturation monitoring. So it's almost real time, and the data is, the wells, as I said, are all intelligent. They are instrumented with state-of-the-art sensors. The data is sent to the GOSP, and then from there it is routed to our desktops. A lot of lessons learned. I'm not going to go through in detail. Definitely, it requires teamwork. You need to have everybody on the table when you're doing a project like this. Obviously, one of the main objectives was to develop the knowledge base for CO2 recovery and sequestration. That has been accomplished. And we have also developed capability in many, many things. There were several operation issues, as this was the first time we had implemented this. So they were identified, addressed, and resolved. Sequestration of CO2, as I mentioned, 60% of the CO2 that we injected has been retained. And very important part of this project, or any project in my opinion, is the personnel training across the entire upstream chain. I would say rather across the entire company. And this has resulted in a huge reduction in carbon footprint, and it has been a successful pilot. And I think that one of the things that we must remember, that the oil and gas industry is really the right folks, or the right place where we can get rid of the CO2 through projects like this. So in summary, the results have been very positive. We had two main objectives: to sequester CO2 and to reduce the emissions, and both of them have been met. The project is still going on, and we have acquired a lot of knowledge and experience for CO2 sequestration. And in terms of monitoring and surveillance, really, I think that has been the strong point of this whole project. With some world firsts, with some Middle East firsts, and we have learned a lot of lessons. We know that CO2 works, and it will lead to sequestration of CO2. Many operational issues, obviously, any such project will have. Those were addressed. We have developed our capability, and it has been an exemplary project, a recipient of several international awards. And this project is also part of the circular carbon economy and energy sustainability initiative within Saudi Aramco. And this last slide takes you through a journey of the whole project through pictures. So you see the CO2 compressor facility or compartment. It's a massive, massive computer. And then the pipeline and the trunk line and the other facilities that are associated with this. So with that, thank you very much, and I'm open to questions.
Thank you, Sanil. Once again, we will pause for a moment and give you a chance to submit a question in the questions box. And whilst I give you a moment on that, if you've been suitably inspired by today's presentations, it might be time to start thinking about your own awards entry for next year. Keep an eye on the IChemE website for more details, but we plan for open for entries in early March 2022. We don't have any questions, so thank you again, Sanil.
Well, thank you.
We still have two more presentations to go before we reveal the award winner. Next up is another Saudi Aramco entry. Please welcome Faisal Al-Kuruni. And I don't think Mohammed is here. Sorry, we have one. Sorry, can I just, before we go to our next presenter, can I just ask, just a question just appeared now, please, Sanil. What kind of technology is adopted to be called as world's first?
You know, one of the things that we have deployed for the first time in this project is the seismic application. So what we did was, you know, for the entire pilot area, we drilled about 1,000 holes into which at a depth of about 50 to 100 feet below the surface, and we placed seismic sensors there. And then, you know, we had vibrators that were going around the whole pilot area, thumping the ground, and you know, this was to monitor where the CO2 was going inside the reservoir. So this seismic application of monitoring a CO2 migration or plume is the first time in the world that has been done to our knowledge. Just one example. There are many that, you know, we've deployed 22, you know, and there are many examples that I can talk about.
Okay, that's great. Thank you. Thank you very much. And now it's actually time to move on to our next presentation. It's another Saudi Aramco entry. Please welcome Faisal Al-Kuruni.
Thank you. Okay, so you can see my screen, right?
Yes, we can.
Okay. Hello, ladies and gentlemen. We are very delightful to be with you here today as a finalist in the IChemE Awards. My name is Faisal Al-Kuruni, the energy coordinator of the largest oil field in the world, and it's my pleasure to share with you a presentation about an innovative energy management program that Saudi Aramco has adopted to reduce the energy intensity of 14 oil and gas separation plants. As you know, energy efficiency is one of the major pillars that needs to be considered seriously today more than ever to enhance life quality and have a sustainable future. And with all the efforts that governments and big companies have been putting to address climate change challenge, protect the environment, and achieve improved energy efficiency, A performance plateau can be rightfully expected at some point down the way. However, with innovation and ambition, such plateau can be overcome, and we can have no limits for improvement. And this is what I'll be presenting here. So first of all, let me shed some light on gas oil separation plants, or GOSPs. GOSPs are the first processing stage of crude oil after its extraction from wells. At the GOSPs, the crude oil is separated into 3 products, as you can see in the slide: oil, gas, and water. Oil and gas are sent then for other facilities for further processing. On the other hand, water is injected back to the reservoir by high-pressure injection pumps. Besides producing high-quality hydrocarbons, we ensure that our emissions are minimized by enhancing the energy efficiency and reducing the energy intensity at our facilities. And one universal key performance indicator used to gauge energy performance is energy intensity. For the GOSPs, the energy intensity, as you can see, can be defined as the power consumption to the amount of useful product. And by useful product, I mean oil and gas. The produced water, on the other hand, is excluded, which represents a big challenge. However, the innovative energy management program that we have implemented has helped us achieve a marvelous improvement that reduced the GOSP's energy intensity in spite of the highlighted challenge. And looking at the equation here, to reduce energy intensity, we either need to reduce our power consumption or increase our production rate. Now I'll walk you through the main optimization tools and initiatives that our energy management program has adopted to reduce energy intensity. The first initiative is Aramco Invented, which is a mathematical algorithm using GAM software. This model easily and quickly identifies the optimum mode to produce the monthly oil target from the 14 facilities my department operates. To have it oversimplified, it tells us to increase the production from plant A and decrease the production at plant B to reduce the number of operated pumps and compressors. And to achieve the most out of this model and to reduce the energy intensity to the lowest possible value, a massive pipelines network called swing lines was constructed. These lines divert crude oil from one facility to another, as you can see here. The objective is once again to optimize the number of running equipment. So in summary, the mathematical algorithm we invented supervises the operation of our 14 facilities by reviewing the process parameters and predicting the most energy efficient mode of operation. Armed with this algorithm and the swing lines network, our energy consumption density has been reduced beyond expectations last year's. Consequently, the energy intensity has been reduced. And as we have established already, another way to reduce energy intensity is increasing the production, which takes me to the second tool our energy management program has, which is also Aramco Invented. This one, though, is to revive dead oil wells and consequently increasing the hydrocarbon production. The beauty of this invention is that it increases hydrocarbon production without any increase in energy consumption by utilizing an ejector and hence leaving a bigger positive impact on energy intensity. And for ejectors to work, they need 2 inputs. First, a motivative source or high pressure source and low pressure source. In our oil wells reviving system, the motive source of the ejector is the pumped processed oil leaving the GOSP. On the other hand, the low pressure source is the dead well. The output of the ejector is then an intermediate pressure mixture that is processed at the GOSP. Unlike the conventional practice to revive oil wells through the high pressure test trap, which is a pressure vessel inside the GOSP, the ejector eliminates gas flaring entirely. In addition, it has a higher reviving capability due to the higher differential pressure obtained from the shipped crude oil compared to the conventional practice. Hence, once again, maximized production, and minimized energy intensity are achieved. And a third tool that our energy management program has is an innovative approach that also reduces energy intensity by maximizing hydrocarbon production through gas flaring minimization. This tool is the flare gas recovery system that we have commissioned. As you can see in the graph, a multi-phase ejector is placed to recover the gas in the flare header. The high pressure source is from the water injection pumps. The resulted intermediate pressure mixture is then returned to the plant, and hence flaring is entirely eliminated. The otherwise flare gas is reproduced, production is increased, and energy intensity is reduced. The last tool our energy management program has is the effective monitoring of the total number of the total power consumption in general and the significant energy users performance in particular at our facilities. This has been accomplished by state-of-the-art dashboards that provide real-time data of the significant energy users at our facilities. This is to ensure that the power consumption is being optimized by avoiding unnecessary equipment operation. So in summary, the energy intensity improvement has been achieved in spite of major challenges we had. And the success of our energy management program led to improving the energy intensity at our 14 facilities by 6.4% in 2019. In 2020, a further improvement was also achieved by 4%. This is of a great importance to energy efficiency continuous improvement and for us to protect the environment. So this is the end of my presentation, and here you can see my email address if you need to ask me any question or email me for any reason. Thank you very much for listening. If you have any questions, I'll be happy to answer.
Thank you very much for your presentation, Faisal. If you'd like to know more about this presentation, please get in touch via the questions box. We don't appear to have any questions, so it's time to move on to our final presentation of the day. Our next presentation showcases the joint entry from the University of Malaysia Sabah, Commerce Galaxy Palladium Consolidated Industries, Zeta and the Tokyo Institute of Technology, already winners of the IChemE Malaysia Sustainability Award this year. Please welcome Rosalam Sarbatli.
Hello, thank you, the MC. It's the last presenters, you know, maybe everyone feel very tired already listening a lot of technical things, yeah. So, but anyway, first of all, I would like to introduce myself. I'm Rosalam Haji Sabatli. I'm from University of Malaysia Sabah, a professor doing on a membrane, nanofiber, and environment. That is my research, basically. So let I introduce a little bit first. What actually UMS? Probably in here nobody know what is UMS. Actually, UMS is one of the public university in Malaysia, which is we have 20. So I have to introduce anyway, and we are located in Borneo Island in Sabah, which is what last time was the colonial of Borneo as well, during I think early 18th century, and even after that until Malaysia become independent. So my collaborator from Zeta Limited Japan, one of the company that produce machine, or they call the so-called, we have a machine to mass produce the nanofiber in the form of membrane or the fiber itself. And another collaborator is from Tokyo Institute of Technology Japan, which is one of, I mean, because the Zeta is the spin-off company for Tokyo Institute of Technology, and they collaborate with me since 2012. And the local company also collaborate with us. There are two local company, Thomas Galaxy, and another one is company is also local, that helping to make sure that this project actually can be delivered to the people. Okay, before I talk about the problem here, we know in Sabah especially, you know, Borneo, one of our issue is our land space is quite huge, and this is very difficult for us to supply a clean water. Especially, we know that Sabah, one of the place where the clean water is not even reached, just around probably about 60% of their population. The rest still doesn't get access to the clean water. That is the first. Secondly, also we also have a geographical which is very huge, and this is allow us to think how we could supply also the energy. So these are two things that become a problem, but the more severe is the clean water. So especially those who living in the coastal area where the river is considered salty. So, okay, that's the real problem. So therefore, we try to invent, we have invented the process, the latest process, which actually using the latest technology, which is membrane distillation. And in this case, we even use the nanofiber membrane in order to increase the capacity of the membrane use. So a little bit brief about the history of my project. Actually, I was trained in UK by Professor Emeritus John Howells, one of, I think, the prominent professor in membrane. And we know that membrane has been started since 1960s by Saudi Rajan. Then after that, I was trained there. And finally, I came back to Malaysia, and we see that this is a problem. How are we going to help the rural people in terms of getting the access to clean water, while we also have a problem of the energy supply? So therefore, if you look at the history of the membrane, people talk about reverse osmosis. This is the latest technology that people produce clean water from the seawater. But what is the issue actually? One of the issue is we know that reverse osmosis require around 50 bars, the pressure which allow to drive the water to passing through the membrane, this is a resistance very high, and we need a lot of energy that required, and we don't even be able to use that third grade energy, for instance, from solar or from other things. So because it's very difficult. Secondly, because an isolated area is very difficult for us to transport a massive and complicated technology into rural area due to the maintenance reason. So therefore, what I have done since 2012, we have collaborated with the company Zeta Limited. We invent the membrane because I know how to do membrane, but one of the issue of the membrane, the new technology that we know that in producing water is membrane distillation. But one of the major issue on the membrane distillation, actually the production of water is very little. We talk about only just about probably 0.5 to 1 liter or even more per square meter of the membrane. That's the drawback. Although even membrane distillation, we use a very low temperature, which is just around 40 to 70, but unfortunately, the production is still limited. So this is making, if you look at membrane distillation worldwide, it's not really being commercialized due to that reason. Yes, of course, we can increase the numbers of membrane, but once you have a problem, especially the penetration of the water, or they call it water intrusion in the membrane, then you need to clean up, and this is making it a problem for the system to be run. Okay, what's our invention? One thing, when we look at in terms of the productivity is lower, the only problem is membrane is they are not open pore. So what we do is we invent the nanofiber membrane, which is they have an open pore but rarely hydrophobic. So from that, we allow the partial pressure of the water from one side to the other side to take place. So therefore, we can increase. It means that we reduce the membrane resistance and allow only vapor to passing through. So this is the first thing. Then from the other side, we collect the membrane. This process we patent. We have patent it under the WIPO, and I have the patent. I have two patents in it. One is call it membrane distillation, which is to recover the energy and to recover the water. But another issue is I just mentioned earlier is the energy. Where we get it? So there are two things energy required. One is to transport the water through the membrane. That one we use the what we call it we use the water heater, and usually we use just conventional one. That one is just to heat it up the water, and they will passing through the membrane, and this will be able to allow us to increase the temperature more than 60 to 70, or sometimes even reach to 80 degrees C. And this will be no problem. The second problem is how we're going to be get the power in order to run the pumping. Although the pumping is very little, because they only use to move the water around the system, However, one of the major issues, we are in the rural area. So therefore, I think last time we do a new invention, they call it osmotic membrane distillation. By using the osmotic, what does it mean? Once you extract the water from the seawater, they create the concentrated seawater. This concentrated seawater, again, we're passing through the PRO, or they call it pressure retardant membrane, or we call it osmotic membranes, more easy to understand. Then from there, we'll be able to run the turbine. Unfortunately, the amount of energy still is not yet be able to really support, although they can run some of the small pump to run the system. So, but anyway, that's not really an issue, and we can have also the solar power on the daytime, while on the nighttime we can use the seawater, which is concentrated seawater, to allow the turbine to turn. So basically, both of them are combined. So it means that we'll be able to produce fresh water even in the rural region or isolated area. So that I think very clear, that already explained. And secondly, just to confirm, if you want to know further about my research, I have written one textbook. They call it Membrane Process for Water and Wastewater Treatment in Rural Region, published by IGI Global 2020, which is published in USA. And it became the textbooks for many places. And that book allowed us to understand the fundamental behind it. But the outcome, if you look at the outcome that we have done, we received the fund from Minister of Science and Technology, actually, of Malaysia. We thanks to them in 2015. We have assembled, of course, there are something that still need to improve, especially if you talk about how to make the process consistent. Because once you have the water intrusion, this is become the disaster for the system in order for you to clean and also to dry up the membrane. So this one is still under investigation. So how we can make it the process become smoother. So again, that is my whole presentation. The only thing, lastly, I want to just little bit advertisement for my new books. They call it Hikmah or Wisdom, Unfolding Mystery of the Universe, which is around the thickness about 480. We are talking about from the creation of the universe, from the beginning of the universe until the end of the universe, and also what the people want to know. So hopefully you can support it. Available online. You can go through Amazon, maybe you can go into Waterstone bookstores in UK and other store in US. So this is already well known, just published September 2021. So thank you very much. If you have any question, I try to answer anyway, it's possible. So beyond my capability and capacity. Thank you very much.
Thank you very much. We have actually a question. Do we have a scaling effect? Is there a scaling effect in the heating system? If so, how do we overcome it?
Okay, which scaling that you mean? Because there are two places that scaling can happen. One is actually under the, it's a normal one, which we heated up the heat. The rest, it will not a problem, since the membrane distillation is working under almost atmospheric pressure. So the scaling is not really an issue in this case. Yeah, that's what I can tell. And also, of course, we do some pre-treatments before the water being injected into the membrane distillation, or before they go into the heating coil, or they call it. We use actually titanium coated glass, which to heat it up the water into around 40 to 70 degrees C. So if you talk about scaling to the membrane, that's not really an issue. The issue I said is actually the water penetration or water intrusion. Then you need to clean, you need to dry up the membrane. Those who study membrane distillation, they understand fully this problem. But conventional membrane, one another problem is the production is very low because of the nature of the membrane. They have only very small pore size that allow only very little vapor can passing through. Thank you.
Thank you very much. We don't have any other questions, so it's time to move on, and we have reached the moment that we've all been waiting for. It's time to find out the winner of the IChemE Sustainability Award sponsored by Johnson Matthey. Before we do that, I'd like to thank all our finalists for joining us today and for taking the time to share more details about the fine work. I'm sure you all agree it's a fine, diverse range of work on show. Let's start by announcing our highly commended entries, and they are Saudi Aramco and the joint entry from Future Bay and Otto Simon. Well done to everyone associated with those projects. But now it's time to announce the award winner. And to do that, we'll hand back over to Johnson Matthey's Arsley Anderson.
Hello. Okay, so I'm back on. I guess I'm no video on this one. Is that right? Oh, hang it. Yep, here we go. Share my video. Yep. Okay, so thanks to all the finalists, and I'm proud to announce that the winner of the IChemE Sustainability Award, sponsored by Johnson Matthey, goes to Saudi Aramco's carbon capture and CO2 enhanced oil recovery development project. So congratulations to Saudi Aramco and Sunil and all the team there. Great knowledge in terms of advancing carbon capture, CO2 carbon capture. So well done.
Thank you very much, Ashley, and congratulations, Anil. How does it feel to be an IChemE award winner?
Thank you very much. Thank you very much. And I, as you can imagine, this kind of a project requires massive team effort, and I dedicate this award to the entire team that worked on it. So thank you, IChemE, for selecting this as the finalist, as the winner, and we are very appreciative, and this work shall continue.
Well, congratulations once again, and thank you to everyone for joining us today, especially all our finalists and our sponsor, of course. And we have still more IChemE Award webinars to come this week. We'll be back this afternoon to announce the winner of our Farm Award. But that's all for now. Thanks very much for joining us.
Thank you.
Goodbye.
Bye-bye.
Thank you. Well done, Sunil. Thanks, Cassandra.
Thank you.
Mara.
Thank you very much.